Suppose you had a function like y equals 2 to the x power. That would take the number 3, so in goes 3, plug in 3, you get 2 to the third, and that would give you 8. But what if you wanted to go this direction? What if you had an 8 and you wanted to try to figure out how to get back to the input, which was 3? So in other words, we need an inverse function for an exponential function. And the inverse function for an exponential function is a log. Log, we'd say base 2, so we're keeping the same base that we had up here, base 2. And then the answer to this was 8, and that would give us back to the 3. So b to the x equals y if and only if log, we're going to keep the same base, so base b. We're going to take the answer, which was y, and it's going to work us back to the input, which was x. When you have log base b of y, it literally means b to the what power equals y. In other words, you're trying to figure out how to take the base that you have, which is b, and make it equal to y, which is the answer that you have, and you're trying to figure out what this exponent would have to be right here. All right. So let's look at the first one, 1a. The base is the little number down in the bottom. I like to think of them as being in the basement. You see them down here? There's the base, okay? So this is the base, 2, turns into a 16 by using what power, right? So 2 to the what power equals 16, and then of course the answer is 4. So let's look at the next one. Find the base. He's the little guy down in the basement. The base, 3 to the what power gets me 1. And then of course we know that anything to the 0 power is 1. So the answer to this one is 0. Most of the time we're not evaluating logs. Most of the time we're trying to take a logarithmic equation and rewrite it as an exponent, or an exponent equation and rewrite it as a log. If you can work back and forth so that you can go from a log to an exponent or an exponent to a log, you can take really hard problems and you can make them very easy problems. When I'm working a problem back and forth between a log and an exponent, I remember ELBA. Well, what is ELBA? So ELBA is a little way to remember that the exponent is equal to the log base answer. Okay. So in other words, if I do ELBA here, ELBA, exponent equals log base answer. So what does that mean? That means that 3 is the exponent, 2 is the base, and 8 is the answer. And I'm done. Let's do it again here. I'm going to write down ELBA. And then I'm going to plug everything in for my problem. 2 was the exponent, 4 was the base, 16 was the answer. Okay, let's try it again. ELBA. This guy's the base. Okay. This time the ELBA goes this way. Elba. 3 is the base, y is the exponent, 7 is the answer. Elba. The exponent was 2. The base was 12. The answer to the problem was x. We're going to need to be able to go back and forth between a logarithmic expression and an exponential expression if we want to be able to solve problems. So here is a perfect example of that skill as a necessary part of solving an equation, right? So we're going to think Elba, the exponent is equal to the log, base, answer. So let's identify that this guy right here, this little tiny guy down at the bottom, is our base. This guy over here is the exponent. And this guy right here, next to the base, is the answer. We've taken a problem which looks very, very complicated, and by rewriting it as an exponent, we've turned it into 16 equals x plus 3, which is a very easy equation, and of course we just get x equals 13. Let's do it again. Elba. This is the exponent. This is the base. So 3 to the third power equals, there's the answer right there, 2x minus 1. So I get 27 equals 2x minus 1, and I get 28 equals 2x, and I get x equals 14. So again, we went from very complicated to very simple. Let's take a look at how to graph logarithmic functions. So let's start by graphing an exponential function, right? Here's an exponential function, y equals 3 to the x. So if x is 0, this is 1. If x is 1, this is 3. If x is 2, this is 9. Right, so here's my function. We already know what these look like, right? Now, we're doing the inverse function, right? If this is f of x, then this is f inverse of x. So remember how we were finding inverse functions before? We were playing switcheroo with x and y, right? So what I'm going to do is I'm going to take all of these guys and switch them. So if this contains the point 0, 1, this guy contains the point 1, 0. And if f of x contains 1, 3, inverse of f contains 3, 1. And if f of x contains 2, 9, of course, the inverse is going to contain 9, 2. So when I plot these, 3 and 1, 9 and 2, my graph is going to look like this. And because we played switcheroo, where the x's became the y's and the y's became the x's, remember that that meant that all inverses were mirror images or reflections over the line y equals x. So the red line is the exponential. Those are the ones we've been graphing for the last 2 days. The blue line is the logarithmic. Notice that it looks just like the exponential, but it's been reflected over the line y equals x. So looking at the blue line, notice that the domain, or the x values, are now all greater than or equal to 0, right? So 0 to infinity. The y values are going to be all real numbers, right? Because the blue line goes all the way from negative infinity up to positive infinity. Because it never reaches 0, there's no y-intercept. And the exponential functions have the y-intercept 0, 1, but because we switch the x's and the y's, the logarithmic functions have an x-intercept of 1, 0. So when we were graphing yesterday, we were always going 1 point up from the origin today we'll always go 1 point to the right of the origin. So let's look at graphing some of these using transformations. Okay, so first thing we want to look at is this guy. Sorry, that line is going to the wrong spot. It's supposed to go to B, so let's adjust that. So the B is the base, right? Remember, the base is going to tell us what the steepness is, right? Are we going by powers of 2 or powers of 3 or powers of 5, whatever it is. Then we've got this guy right here, right? This is going to be shift left and right. Then we've got this guy right here. This is going to tell us to shift up and down. And then remember that the leading coefficient, if it's negative, it's going to flip my graph upside down. Okay, so now let's graph some of these. So the first thing I'm going to notice in problem number 5 is that this whole graph is going to be shifted down 2. So down 2. The other thing I'm going to notice is that this is negative, so it's going to be flipped upside down. And the last thing I'm going to notice is that the base is 2. So this is going to grow by powers of 2. Because I'm switching the input and the output, I'm going to put my x on this side and my 2 to the x on this side. When x is 0, this is 1. When x is 1, this is 2. When x is 2, this is 4. When x is 3, this is 8. It's the same table we made yesterday, but all we did was we switched the input and the output. So this is going to tell me how much to go over and how much to go up. So I'm going to go over 1, up 0, over 2, up 1, over 4, up 2, and over 8, up 3. And there's my graph. Now what's the matter with this graph? Well, I forgot to flip it upside down. So let's flip it upside down. Oops, let's go back. There we go. Let's flip this upside down. One more time. There we go. Okay. Okay, let's look at number 6. So the first thing I'm going to do is I'm going to shift this up 3. And I'm going to shift it 1 space to the right. Okay, there's my origin. This is going to grow by powers of 3. So like this, right? Again, this is over and this is up, right? So I'm going to go over 1, up 0, over 3, up 1, over 1, up 0, over 3, up 1, over 9, up 2. Let's look at problem number 7. This is going to go up 3. Now we have a little thing we have to look at right here, and that is negative x. Remember that when you have negative x, instead of flipping your graph upside down, it's going to flip your graph from left to right. So notice here that these were opening to the right. In problem number 7, my graph is going to open now to the left. So as I graph my powers of 2, I'm just going to go left instead of right. So up 1 over 2, up 2 over 4, up 3 over 8, and there's my graph. All right, I want you guys to try 8, 9, and 10 on your own. You can check the key to the notes in the locker, and you can check the key to the homework in the locker as well, and I'll see you guys tomorrow.